Hello, my fellow YouTubers. This is Roy back again. Let's do a couple quick experiments and I will explain them to you and I hope you enjoy. Tonight we're going to do a couple different things that I see out there, and these are out of the box thinking, I would call it. And this first experiment, we're going to take the compass here and we're going to check the poles. We're all north. Alright. And coming out of here, right now it's not showing anything, but it should be in north as well. And I'm going to set the wheel up here, put it in the middle so it doesn't have any kind of reaction. This right here is the voltmeter, and it'll kick on, show how many volts. I got three 12-volt batteries tied together, and it'll show up 35, 36 volts, so the batteries are a little bit used up. Down here, I want you to see, so everybody knows in the future, my next video on, I am going to clear off this section here, and I am going to make a schematic, a blueprint of everything, what the layout is. So every time we do an experiment, we'll go to the schematic and you'll know where everything is so you can build it. So that's my promise to you. I'm going to become an electrical artist, and that'll be my schematics and write it out. So that'll start immediately, starting tomorrow. So on top of that, I was thinking, I said, well, here on this gap down here, you see I got it always leaning towards this connector, and then on this connector, I don't use it, but I showed you in my experiment how to use it. On this experiment, we're going to, I got the negative side coming out and running into the negative side of the voltmeter and the negative side of this battery. This is going to be our charging battery. Hear me out. So with the Bedini wheel, you have the wheel turning and you're charging a battery, okay, off the back EMF. Now on the back EMF on the Bedini wheel with a transistor, which we're going to have to come over here and grab a transistor. Yeah, I'm sure I got one laying around. Here we go. So the way the Bedini setup is, this is the Bedini circuit here. So you look at the transistor, you want the two pins, it's a 2N3055. And you want the two pins on the top side, because you'll see if you turn it upside down, they're on the low line. If you turn them up, they're higher. So when you turn them up high like that, to your left will be your base, to your right will be your emitter, and the chassis itself is the collector. The collector is what puts out the voltage and what is biased to the emitter. The emitter is the negative side of your power source, and on the base side, that is your pulse coming in to turn the switching on, but it biases between the base and the emitter, and then between the collector and the emitter, they bias each other. Pretty interesting stuff. But on the charging, back charging is really not coming off the bifilar. It's really coming off the fact that the top of the collector has a dioide with the positive, with the ribbon facing outward. And that's what we're doing here. So there's we're coming off the negative side. We're off, right here we're coming off the positive side. So positive in, diode, ribbon out, and then we're going into the positive side of the battery. The negative side is coming up and The negative side is connected to the other side of that back part of that. See right here, so if you go over, it touches, makes contact. So that, with a diode in place on the positive side, that will charge. Now this battery here is the voltage here. We'll see an increase in charge. We'll run it for a few seconds. Watch how it fluctuates, and then what it comes down to, you'll see that it's speed charging the battery. And it's also desulfating, which is batteries through time build up corrosion down bottom, and once it touches the bottom plate, it shorts itself out, I believe, and your battery goes downhill. So desulfating is taking that stuff, I guess, and it's putting high voltage back in through a rate of change. So the voltage, because of the pulsating, probably, we're going to look and see, probably doesn't go up to high voltage, but it's the rate of change and the fact that you're pulsating that battery is desulfating plus charging. So on the backswing of this right here, we're charging a battery. Then we're going to get into two other experiments. We're going to put a coil around this core, and we have it with a load on it is one of these 4.5 watt light bulbs. Then we have this coil here come into this other light bulb, which is LEDs, like 10 of them or more than that, but 4.5 watts. And we also have an iron core, a nice piece of copper, 1/2 inch thick, 2.5 inches wide. It came off a buzz bar, I guess you call those. Got that. And we're also going to use a piece of, yes? Can we do it in cash? Then yeah, we're fine. We'll just take care of the other business I talked to you about tomorrow. All right, cool. So we'll use this regular solid iron versus as a core versus this laminate iron, and we'll see if there's any differences in the light. This meter will tell us volts coming in. It'll tell us amps going out, and it'll also down here tell us the wattage. So there's an experiment here that I've been wanting to put out there. It's how do you gain back whatever you lose through resistance and resistance, because a load is resistance. So what do you how do you gain back? And this is a system here that I'm pretty proud of, and you guys, the schematic will show up tomorrow, and it will be something you can start off with exploring on getting the energy back. And we're going to demonstrate tonight on the more of resistance, the more of a load equals resistance you put on. It doesn't take any energy from the action, which is the coil itself, the oscillator here. When you put a load to it, it will draw more energy. And what we're going to see here is a way that I found that you could disconnect the lens effect and you could gather energy without putting the load on the existing starter, or call it seed energy, which would be the battery is the seed energy. We're coming out and we're going into this coil, we're oscillating it, and now we're going to add a coil over to the core, and we're going to split the two coils on one core. But what we're going to do is reverse the natural direction of the wire. So it creates a dipole in a fine, minute place in between this coil and this coil. So this coil is north facing out, and then we're going to make this coil to where it's south. And it being a south, it's going to create a small dipole right here in the dielectric in between both coils, and that counter space, we're going to call it, out here becomes another dipole. Now this dipole out here, if you were to take a core and you were to put it in there, you're going to put a load on here, and you're going to see more amperage go up and more wattage go up. Now hear me out. This is going to blow your mind, you guys. This is going to blow your mind. Let's start off very simple and easy right now with the first experiment, and I call this deflecting electromagnetic waves. And deflecting electromagnetic waves is going to be done in this manner. I got this thick copper, okay? And obviously north is going to be coming out, and it comes out and comes around and goes back around. So basically it does it this way on this side and this way. Now, what you're going to see here is when we just turn this on and tap it and turn it on, the wheel might just move just a hair, but it ain't going to do much. Now, when we take this copper and I put it up here in position, and what we're doing is we're going to come out, we're going to hit this copper here with the direct straight streams coming out, and it's going to reflect it back that way. Now remember, this magnet's a north, this magnet is a north. We're going to push the wheel, drive the wheel from deflection. That's experiment one, and that's not even the best out of tonight's experiments. All right, you guys, let's get this party going. So right now we're just going to, you can see my hand, I'm going to touch the battery, and you're going to see the wheel move a little bit, but not really move. So that's obviously, let's get it to stop. I don't want to get it moving. So now it's going back. All right, so here you go. So it's in the middle, and the wheel's not moving. All right, no wheel moving. Now we're going to put the copper in place, and we're going to deflect the electromagnetic wave. And I'm going to put this at a certain angle. And let's go ahead now. We didn't touch the wheel. Let's go ahead and start turning. All right, let me just get the wheel on. It's a little bit over. Get the point. I'm deflecting it, and it's making the wheel turn. Let's go to the other experiment. All right, so let's let this settle down for a second. We're at 12.77 volts and dropping. As we were doing that, a charge was coming out of my little non-transistor Bedini setup here. And we're charging a battery, so it means we're taking the back EMF in a different way, because we're double slapping, I guess. One's going out and going through the coil, making an electromagnetic field, and the other one is on its back swing because it's drawn in and being pulled right here from one electromagnetic magnet from that magnet there, and then it connects that side and starts charging that battery. So we're down at 12.7 ohm. So right here, I think it's time that I let me see, how are we going to do this? One hand, let's try this. So keep an eye on these two lights, and the first one light up will be the first coil, and then we'll focus on what the readings are here. Fire in the hole. Alright, so you can see the wheels already reacting to what's happening. Alright, now it gets locked in, but if you get it going, it gets unlocked. That wheel right there, for instance, watch this. It'll stay going for a long time. So back over here, we're at 35 watts. We got 1.83 of amp, and that's running the oscillator. 63 to 63.8, 64 volts or watts is what it takes to run this setup right here. Okay, there's your oscillator. Back here, the voltage is charging that battery. So right now you see it fluctuating way above voltage pressure. Okay. Now let's go ahead and go on the tail end of it. So here, let's put this coil in place, and you see the light come on. Coil number 1. Coil number 2, you put up, nothing happening. Alright. So let's check out the difference in the voltage and power. So we're at we got it out. So we're at 1.77. Let me see if I can get both of this together. So if you can see it, you're at 1.77 and 61 watts. Now we're going to go ahead and put the light on, and we dropped down in amperage, and we're dropping down in wattage. How's that happening? Now remember, we're creating a dipole in the center. Let's see if we can step it up a little bit. So we're going to take this laminate core, and we're going to go ahead and stick it in, and let's watch. Keep an eye on that light. Alright, keep an eye on that light, how bright it is. And let's keep an eye on the power and the amperage. Wattage and amperage. So 170 and 59. So we're going to come in here and we're going to add some more induction. Look at the difference in the light. Okay, look. It's crazy how much brighter it gets. I'm adding this. And now let's look at what's going on with that. So without it, we're at 165 of an amp and 59. And now we're going to add it in. Power goes up on the power goes up. It has a little droppage here. Sorry about that. Let me get you guys situated. Alright, so we got this. Now we're going to put this coil back in place. Now this light should go on. Now it's time to get real. So here we are. So we got this coil. Alright, so without it in, 56 watts and 1.64. Then we're going to go ahead and turn it in. Lights bright, and we're at 158 and 55. So we drop down in wattage and amperage, okay? And that's having the load on the outside. Figure this out. Now let's go ahead and we're going to insert, let's get that there. We're going to insert this coil in that core into there. A couple things are going to happen. This light's going to get brighter. That light's going to light up. And the power or the wattage and the amperage are going to go down. So we're at 157, 159. I thought I seen we're at wattage 55 and 159. We'll go with that. So let's go ahead and put this in. You can see this light is going to get so bright. That light is on. And now we're at 155 and 54.2 watts. So we actually dropped down. Look at me. So I got two coils behind the Bedini setup charging that battery and dropping down in wattage and amperage. $53. Let's go ahead and put the mechanism in. Got all kinds going on there. Look how bright those lights are. Speed kicked up on the double banger. We're going down in amperage and wattage. Riddle me that, Batman. Riddle me that. You guys, thanks for watching. Leave your comments. Hopefully you appreciate the experiments. Like I said, starting tomorrow, I'm going to become an artist and draw out beautiful schematics of what we got, what's in place. And as we do different experiments, we'll add and subtract. And remember this setup here, you come out with one pole and then you put the opposing winding poles, so you compress the dipole between this core and the coil itself, and then you come into the other setup opposing the middle one, and what you're creating is a electromagnetic diode. An electromagnetic diode, you are able to pull energy off of this coil and allow the coil to cool down and use less energy to run it while you have a outstanding amount of loads. So that was 4.5 and 4.5. That's 9 watts. You did not see 9 watts appear on the goings in to run the oscillator, correct? And you did see it drop down as we added more components, just like the universe, guys. It's reminiscent. These experiments are done because I'm thinking of nature. And I want to give a shout out to everybody out there. Angel, Made by One Man, Jason, all you guys. If I left your name out, sorry, but AAA, Clay, A little brain dead right now. This has been intense. Intense. So right here you can see we're up to 12.84 volts. So we went up in charging that battery. Now the system is off. You can see that battery was charged. So we've got to see if anything over Unity is here. These are 7 amp hour batteries. There's 3 of them there. So what I want to do is have 3 running and 3 charging, and 7 amp hours. If you look at the amperage here, we're at 1 whatever it was, 6.4 or 4.9, 1.49, I think, at the end. That's a amp and a half. So amp and a half divided by 7 per hour. That's going to be that'll be, say, 3. So you're taking away 3, 4. So you're taking away, I think you're at 4.5 amp hours instead of 7 because of the load. So 4.5 hours you should be able to operate this. We'll see if 4.5. I just check myself when I get off the video, when I get a piece of paper and a pen. But if 4.5 amp hours is charging as well, then at what point do we have over Unity to where we're not putting any energy? We're putting energy in, we're getting it out. We're not turning anything anymore, so it's not Bedini to where this has to oscillate, because why would you even want something mechanical when you can oscillate it and create an event? And you can see how my brain works, where I expand the events, and these dipoles are expanding and how they're acting, and the fact that if you could have a single coil with a coil in the middle and a coil on the outside, that the coil in the middle set in a certain way would allow the magnetic flux to go through and create the outside to be the dipole of the opposite of the originator, which would be this. That means this section and this section would be the true dipole, and this coil in the middle would be a electromagnetic dioid. And you're only allowing one way going with the electromagnetic, and you're taking from there because the lens effect doesn't kick in, because it doesn't know that you're interrupting, creating a node in a sense. If you want to talk musically, you're creating a node, but here you're expanding the node, so it doesn't know there's a connection, a tap in the middle in this center coil. All it knows is that that outside coil is abiding by the lens effect. All right, guys, leave your comments. Hopefully you appreciate 28 minutes of pure pleasure on my part. Thank you.